Hello everyone and welcome back. Let's talk about the two different ways that we have for signing payloads of JSON Web Tokens, what's the difference between both, and which one should we choose for our application. Now let's have a look here at our first example. So this is creating here a JSON Web Token, and it's doing so using the default algorithm, which is HS256. This means that the signature of the JSON Web Token will be produced using the SHA-256 HMAC algorithm. To understand how this signing mechanism works, let's start by creating a JSON Web Token. So we are going to do npm run, and then we are going to run this example, JWT-HS256. This is the signature mechanism that we will be covering in this lesson. And here we have it. We have our JSON Web Token, which has this payload here, and it has been signed with this secret key. To prove that this is a valid JSON Web Token and better understand how this type of signature works, let's copy paste this complete string and switch over here to the browser to jwt.io. So we are going to paste in here our JSON Web Token. So as you can see, this has been decoded. We can see here the header, the payload, and the signature is still marked as invalid. Now, if we type in here in this box the correct password, the signature has been verified. So this is a valid JSON Web Token. Let's now talk about how this signature here, the third part of the JSON Web Token, was produced. So this is what is called the hash-based message authentication code, or HMAC for short. And we're going to go over what is exactly a HMAC code. The goal of the MAC code is to prove that the message is authentic, meaning that it was sent by who we think it was sent. That's what the signature, which is the third part of the JSON Web Token, proves. The signature is a MAC code. How is it produced? We're going to take the payload and we're going to take a secret key. We're going to hash everything together using a hashing function such as, for example, SHA-256. The result of that operation, which is the hash output, is the message authentication code itself. So the idea is that we are going to send the message, and together with the message we are going to send the message authentication code. And that's exactly what we are doing with JSON Web Tokens. So the payload part is the data and the signature part is the message authentication code. The receiving party is going to validate the content of the message in the following way. It's going to take the data, which is unencrypted. It's going to take the secret key that it also possesses on its side, and it's going to hash everything together again, trying to reproduce the same hash output. Again, the goal is to check if the message received is indeed correct and to confirm that it was sent by someone in possession of the private secret that was previously shared between the two parties. So if we manage to take the payload, take the secret key, we hash everything together and we obtain the same message authentication code, this proves that the message is correct, because this message authentication code could only have been produced by someone in possession of the secret key. If we assume that the key was not lost, then we can safely assume that this message is indeed correct and it was indeed produced by the sender. This information could not have been modified by a third party that does not have the secret key. Only someone in possession of the secret key could have produced this message authentication code. So this code proves that the message is indeed correct. So this explains why a JSON Web Token is a self-validating token. This means that we only have to look at the token to make sure that the token is correct. We only have to inspect the signature and validate the message authentication code. We don't have to contact a third-party service to make sure that the token is correct, and we don't have to keep it in memory between requests. Those are two key advantages of JSON Web Tokens. Now let's see how do we verify a JSON Web Token in practice. We're going to copy this string and we're going to switch over here to this second example file. So it's called JWT check HS256 because it's based on the SHA-256 algorithm. And here we are going to paste the JSON Web Token, the complete JSON Web Token that we have taken from the browser. We are going to put in here the secret key correctly. So remember, this JSON Web Token is the same that we generated here using this file here. This is the file that we have used to generate a new JSON Web Token. We took it and we have copied here. So now we are the receiving party that has received the JSON Web Token, and we would like to validate that the JSON Web Token is indeed correct. So we don't want to write code that takes the signature here and validates the payload. The library already provides us a solution for that. So we just need to use the JSON Web Token library. We pass to the verify method 2 arguments. One is the complete JSON Web Token with all 3 parts that we want to verify if it's correct. And the second argument is the secret key. Let's see what we receive on the screen as we print out the output. So if we head over to the terminal, we are going to do npm run, and then we are going to pass in the same name as the file, JWT check HS256, without the JS extension. So as you can see, we did not receive any error on the screen, and the output of calling verify is the payload, as we can see. At this point, we have simulated the typical interaction between the sender and the receiver. The sender produced the JSON Web Token using the secret key, and here we have verified it using the same key. What would happen if we would not have the key at the receiving side, or we had the wrong key, or a key that has been meanwhile changed? Let's have a look. We're going to run again the same program. So as you can see, this time around an error here was thrown, so we would have to catch it and handle it. And this is essentially how the HS256 JSON Web Token signature mechanism works. We have covered a lot of ground in this lesson. Let's switch over to the browser and summarize. So this, in summary, is how this particular type of signature, HS256, works in JSON Web Tokens. We simply take the payload, we hash it together with the secret key, produce a message authentication code, and append it to the message. The receiver can be sure that the message is indeed correct. This is because the message authentication code allows the receiver to make sure that this was indeed the payload sent by someone in possession of the secret key. The message is not encrypted, meaning that it can be read by an attacker, but an attacker without the secret key has no way of forging its own messages. Now, this is only one of 2 mechanisms. We have here a second mechanism called RS256. This is the signature mechanism that we will be using to implement our server, and it has a couple of advantages over HS256. In order to understand them, let's talk about a potential limitation of the HS256 signature mechanism. There is one fundamental problem with HS256. Both the sender and the receiver must have exchanged beforehand the secret key. This means that the secret key is needed in many places, in the sender and in the multiple receivers. Everyone has to have that key installed on their system, so more places where the key could be stolen and potentially misused. Also, this means that if we want to change the secret key, we need to change it everywhere with all the parties involved. That might mean coordinated downtime, where all the parties agree that at a certain time the keys will be swapped. It might mean temporary service unavailability, and all of that is inconvenient. RS256, that we're going to cover next, solves all these problems.